All right, continuing on with yesterday's notes, we talked about confidence interval. When we talk about a confidence interval, we're basically trying to look for guesstimates. We're looking for two values. So we can separate the population mean, standard deviation, or proportions, percents. We want to get two estimates that we're going to be in between these two values. We can do with respect to a specific confidence in between two specific values. So if we take a look at the idea of a confidence interval, what we finished out with, we will have a sample size n. We will calculate an interval using z-scores to illustrate the confidence level. The population mean will be somewhere within these two values, this interval. And most of the percentages or confidence levels that we're dealing with are 90, 95, and 99%. So if we take a look at another problem, this is something that we dealt with once again in our previous section. Population of average salary teachers in Ohio is 41,000 with a standard deviation of 1,500. What's the upper and lower bound for salaries that encompass 90% of the salaries? If we remember how we dealt with this, this was our value is equal to our mean plus our standard deviation times our z-score. So looking at our bell-shaped curve, we want 90% of our data values. We want to calculate our z-scores so that 90% of our data values are going to lie in between them. Once again, this goes back to the idea of, if you think back to what we are working on with respect to finding a specific value for the middle 10% or middle 20% or middle 30%. Well, what we're saying here is the middle 90%. So if we look at the middle 90%, we have 45% on each side of our zero here, which means our area here will be 0.4500. Our area here will be 0.4500. So we divide our areas into two different regions. And then we looked at the body of our score, or body of our z-table, and we looked for values that were 0.4500. So we looked and we searched in the body of our z-table, 0.4500, and we were exactly in between 1.64 and 1.65. We have 0.4495 and 0.4505, and we're halfway in between those. So I said you can use either 1.64 or 1.65, but what we're going to use now is the value of 1.65. And we have a negative value here with the 1.65. And then we calculated two values by taking our mean, which is 41,000, and our standard deviation of 1,500. And we looked at using these two values. Our values were 41,000 plus our z-score 1.65 times our standard deviation of 1,500, and 41,000 plus a negative 1.65 times 1,500. So we came down to two values. So the top one was 43,475. And our bottom one is 38,525. So we can say that 90% of the salaries are between these two values. 90% of salaries will be between those two values. Now remember though, when we were dealing with our sigma for the population mean, and we're talking about a sample size. How we calculate our sigma for our sample size was taking our population standard deviation, and this is square root of sample size. We found our value to be square root of, or I'm sorry, sigma divided by square root of n. Which now, when we substitute this in, and we started looking at our value, our sigma, we start using our sample size, our sample mean. So what we have is our sample mean we have z times our z value, and when we substitute in for our sigma, we have sigma divided by square root of n. So rather than dealing with mean, standard deviation, and z up here, we have to now deal with the sample size, and our mean turns into our sample mean. So now we have a sample of 40 teachers. So we have a sample size of 40 teachers, chosen from the population. Their mean salary, so we have a sample mean of their salary is $41,000. Because we're talking about their salary, the sample salary. We have a standard deviation still of $1,500. We now want to calculate a confidence interval of 90%. Well, what's different between a confidence interval of 90% and 90% of the salaries? Well, there's nothing. They mean the same thing. So when we encompass 90% of the salaries, what we're getting is we're getting two boundary values. These up here were boundary values. In regards to 90% of the salaries. When we talk about this confidence level, in this confidence interval, we're looking for boundary values. We're looking at these boundary values. So how we can calculate these boundary values is we can still go back to our idea of a bell-shaped curve. We're still looking at the idea of 90%. 0.4500, 0.4500. We're still dealing with the same thing we did before. The only thing difference now is rather than finding a value, we're trying to find a boundary value. And this boundary values for our population mean can be calculated by our sample mean plus the z value times the standard deviation divided by square root of n. Our z values are still going to be the same, negative and positive 1.65, but now these boundary values are going to be our sample mean plus or minus our plus our z-score times our standard deviation divided by square root of n. So this will give us our boundary value for our two values. Well, we have two values here, negative and positive 1.65. So we have 41,000 plus 1.65, 1,500 divided by square root of 40. And then we have a second value, 41,000 minus or plus a negative 1.65 times 1,500 divided by square root of 40. So we're doing basically the same thing. The only thing that's different now is the standard deviation turns to standard deviation divided by square root of n. So our first value comes down to 41,391.33. And 40,608.67. Now we finish up our confidence interval ideas by writing a statement, and you need to get the statement down here. It doesn't have to be anything specific or spectacular, but you need to get a statement down. 90% of the salaries are going to lie within these, or 90% of the means of the salaries will lie in between those two values that we've just calculated. Or we can say, in regards to a confidence level, we are 90% confident the population mean for teachers' salary is between 40,608.67 and 41,391.33. So we are 90, if I was looking for the population mean, we are going to be 90% confident that the population mean is going to be in between those two values. And that's what we're, once again, trying to guesstimate. As we talked about yesterday in regards to the presidential elections, they were probably 99% confident that Trump was going to be in between these two values. Harris was going to be in between these two values with respect to percentages. Bernie Moreno and Sherrod Brown are going to be in between specific values. So you need to get a statement down to complete the problem. You need to get your statement down. Talk about a confidence interval. CI is your confidence interval. Once again, we will be dealing with 90, 95, and 99%. We have an alpha value. It's the amount of area in the two tails corresponding to a confidence interval. What I like to say, it's basically your percent not confident. So if I'm 90% confident That means 90% of the scores are going to be in between these two values. I'm 90% confident the population mean is going to be in between those two values. That means I'm 10%, which is the stuff on your tails. This out here, if I would add this stuff up, when I add them together, this equals your alpha value. It's your percent not confident. Once again, we are looking for estimates for the population mean. And if we look at the population mean, what we will be saying is, using our confidence intervals, that our population mean is going to be somewhere in between the sample mean plus or minus your z-value for the confidence interval times the standard deviation divided by square root of n. Some multiplication in there. Now, the nice thing about, and you'll get a table tomorrow that's going to be even nicer, but the nice thing about the confidence intervals, working with confidence intervals, before we've always had to do the bell-shaped curve. We put our areas in the bell-shaped curve, and then we had to look at our body of our table and find the z-scores for that. Here is our three main values here. This is our confidence interval. We either be dealing with 90, 95, or 99% confidence levels. The z values that we will be using, if I'm looking at a 90% confidence interval, my z value would be 1.65. If I'm looking at a 95% confidence interval, my z value will be 1.96. If I look at a 99% confidence interval, my z value is 2.58. And you can look at your tables as you do your problems for the day. You can look at your table here and pull out the z value. Tomorrow you're going to get another table that will have them on there for you. So it'll be a lot easier for you to deal with. But for today and for homework today, you can use these values here. Maximum error. We talk about the maximum error. It's a distance, it's the difference between your population mean mu and the maximum distance to your confidence interval. You can put CI in there if you want. Your maximum error. Your boundary values are calculated by x bar plus our z for the confidence interval, standard deviation divided by square root of n. This here is your maximum error. This is your maximum error. So basically, your boundary values are plus or minus this maximum error. Or this is sometimes called margin of error. Your margin of error. Yesterday we dealt with Trump was 52.46. We had a margin of error of 3.2. So we had 52 So this margin of error was 3.2%. So this here was our sample mean. These were our sample means, and then we add or subtract our margin of error. So this here is our maximum error margin of error, how we can calculate our error values. If the population standard deviation is not known, the sample standard deviation can be used. So basically, our confidence intervals, once again, you can change these to CI, CI. Your confidence interval, we can use the standard deviation. That's it from the sample. Reason why? Basically, statisticians just want numbers to deal with. They just want numbers. The sample standard deviation may not be correct for the population standard deviation, but it's close enough. And once again, with statisticians, close enough is good enough for us. We can throw numbers together and we can calculate it out. So basically, your sample standard deviation goes in for your population standard deviation here, and your boundary values for this confidence interval is your sample mean plus or minus your z-value for the confidence interval standard deviation divided by square root of n. Some ideas to pull from this. If you want to be more confident the population mean lies in an interval, you must be willing to trade off with a bigger standard confidence interval. If you want to be more confident, and the reason why is all the values stay the same except for the z-value. If you're 90%, my z-value is 1.65, so I'm not multiplying by as big of a value. Once again, this here is our sample mean plus our error. Well, if this gets bigger, this number is going to get bigger here because I'm multiplying by a bigger number. So I'm going to be at 99% confidence interval. My interval for is just going to get bigger. So it's going to get a little bit wider. To be able to find a confidence interval, the sample size must be large enough. We will use 30. We will use at least 30. We want to have a sample size, once again, law of large numbers. Sometimes you'll be given an error. I want to be as close to this as plus or minus $1, or plus or minus $2, or plus or minus $5. What does my sample size have to be? Well, if I'm trying to calculate a sample size, I can take my z for the confidence interval, standard deviation, and divide by this error, and then have to square it. And that will give me a minimum sample size. So if I have an error, and I'm willing to live with a certain amount for an error, I can deal with an error. How big does my sample size have to be? Well, I can calculate my sample size by z times standard deviation divided by whatever my error is I'm willing to live with. I can divide by that, and then I have to square that quantity. Last thing, we'll go through a problem here. A survey of individuals who passed the 7 exams and obtained the rank of fellow in the actuary's field find the average salary to be $150,000, which is probably more than that now. This problem's 10 years old, probably $200,000. If the standard deviation of the sample of 35 fellows was 15,000, construct a 90% confidence interval. Let's change this. Let's go 95%. Just to give us a, let's go 99%. Just to give us another value. Now, if you're interested in getting into a field, when you get out of college, you're going to get some buku bucks. You're going to get a lot of jingle in your pocket. Go into an actuary field or an applied math field. Okay, every company, every corporation, every insurance company has an actuary field because what they do is they basically make predictions for the company to make the company money. So if we take a look at what we have here, we have survey of 7 exams obtained fellows find an average salary to be $150,000. Okay, standard deviation for the sample of 35. So we have a sample of 35. Their average salary was $150,000. Standard deviation of $15,000. We want to calculate a 99% confidence interval for the population mean. So what we want is we have a 99% CI, and if we look at the previous page, our Z value for a 99% confidence interval is 2.58. So we have 2.58 there. So our population mean is going to be somewhere in between x bar minus the z, standard deviation square root of n, and x bar plus the z, standard deviation divided by square root of n. So we can plug in our numbers. $150,000 minus 2.58 times standard deviation of 15,000 divided by square root of 35. Population mean is going to be less than this $150,000 plus 2.58 times $15,000 divided by square root of 35. So crunching these numbers, we come down to 143, 458, 50. And then 156, 541, 49. So we can finish out our statement. Once again, we finish out with the statement. 99% confident. Population mean. For actuaries. That are fellows is between 143 458, 50, and 156, 541, 49. So we are predicting that the population mean, which is everybody, is going to be somewhere in between these two values. Once again, use the table that we have at the bottom of the page to find the z-values. You don't have to do bell-shaped curves anymore. You can utilize that table to be able to deal with your calculations. You'll have a worksheet. Tomorrow we'll continue working with these. And the rest of the time is yours.